So in this video, I'd like to go through some examples of uh, working both kind of, if I know information about f, what can I say about f prime or the derivative? If I know information about the derivative, what can I say about the function? Using graphs, using algebraic techniques, using tables as well. It's just kind of a hodgepodge of different examples here. So the first example I want to go through here is if I have a graph of f, and I want to sketch a graph of f prime. Well, f prime is the derivative, but the word derivative is not very helpful in helping me know what I should do here. So I think to some of the different things I can call a derivative of a function. I can call it instantaneous rate of change. Well, that's not very helpful. I can call it slope of a tangent, and I can call it slope of a curve. And slope of a curve, I think, is going to be more helpful here. So if I think of this as instead saying, I want to sketch a graph of the slope of f of x. That means that what's being plotted on this graph are these values of the slope. Well, fortunately, I have a piecewise linear function here for f. I can see from here, where x is -3, to here, where x is 1, the slope has a constant value of -2. So that means for f prime, that means the derivative of f, the slope of f, has a value of -2 for all of those x's. So from -3 to +1, I have slope values of -2. Now remember, when I'm sketching the slope, or I'm sketching the derivative of f, I'm sketching the values of the slope. Since the slope is a constant value of -2, that's why I have a horizontal piece here at -2. I'm going to kind of ignore the endpoints right now. From 1 to 3 for the x's, I can see that my slope is +2. So from x equals 1 to x equals 3, I have slopes of +2. Then from 3 to 5, I have a slope of 0. So from 3 to 5, a slope of 0. And then 5 off to 10, and I didn't pick a big enough coordinate plane for this, but here's where 10 would be. From 5 to 10, I have a slope of -1. So when I sketched the graph of f prime, or I sketched the graph of the slope of f, I ended up with a series of jumps. So it's not a continuous graph for the slope of f. So I need to think about, what am I doing? What about if x equals 1? Is it going to have a slope of -2, like right here, or is it going to have a slope of +2 here? And this is where those one-sided derivatives come in. I can see as I approach 1 from the left, the slopes are all -2, but as I approach from the right, the slopes are all +2. Well, for there to be a slope here at 1, the slope from the left and the slope from the right have to be the same. Since they aren't, there's actually no slope at x equals 1. So I would need to put open dots on both pieces here when x is 1. For the same reason, there's not going to be a slope at x equals 3. There's not going to be a slope at x equals 5. So I need to put open dots where x is 3 and where x is 5. Now the endpoints at x equals -3 and x equals 10, that's where the controversy comes in. I was taught that it's okay to go ahead and put a closed dot here at an endpoint of the domain, because even though the two-sided derivative doesn't exist there at x equals -3, because it's the end of the domain, it's not possible to have a two-sided derivative. So I just settle for the one-sided. But there are other mathematicians who say, well, no, a slope can only exist if the two-sided derivative exists. So if I were to put an open dot, like say at x equals 10, because that's the endpoint of the domain, that is acceptable as well. So for endpoints of domains, either open dots like here or closed dots like here are acceptable. It's just kind of pick what you're most comfortable with. If it were entirely up to me, I personally would put the closed dots, but because I don't want to make that decision for you, because it is a personal decision, in class you will see me use both closed dots and open dots at the endpoints of domains. So then if I move on to my next example, I have a typo in my notes here. We are going to be sketching the graph of f of x, not the graph of f prime. So some information I'm given about the graph of f. I'm told f is continuous. Well, I can't really draw anything yet, just knowing it's continuous, but that's good to know. I'm not going to have any discontinuities in this. So no jumps, no holes, no moved points, no oscillations, no vertical asymptotes. I am told a specific coordinate when x is 0, f of 0 is 2. So I do know I have a point right here. I'm then told f prime of x is equal to -1 when x is less than -1, and f prime of x equals +1 when x is greater than -1. Well, that's not going to be very helpful in terms of thinking of it, but if I think of f prime, the derivative, as the slope of f of x, I'm going to start with the part where x is greater than -1, because the point I know, the x is greater than -1. So at this point of 0, the slope, because 0 is greater than -1, the slope is a +1. So I can draw a line with a slope of +1 there. And kind of moving off to the left from it, it should still have a slope of +1 up until it hits x equals -1. Now, because it is continuous, I do know there's a point right here at -1, -1, at -1, +1. But now, for x's that are less than -1, I need to have slopes that are -1. So slopes of, I can draw a line. Hopefully your lines look better than mine, with a slope of -1. And there's a sketch of the graph of f. Now, I've been saying you need to know the difference quotient because that is the definition of a derivative. The idea that we are finding the slope between 2 points and moving them infinitely close together. The way that the AP exam actually sees, do you know this definition, is they give you a problem like this. They give you a table of function values and they ask you to estimate a derivative value for a specific x, but that x isn't in the table. So what we do here, though, is we approach it like we do with the difference quotient. We said, well, I'm going to find the slope between 2 points and move the points as close together as I can. Now, in this case, I'm not going to be able to get them infinitely close, but it does say estimate, not find perfectly. So it's acknowledging that it's not going to be perfect. So now it's a matter of which 2 points do I pick? Because technically, I could pick x equals 0 and x equals 5, and say, well, that is going to, if I find the slope between those 2 points, that does give me an estimate for k prime of 2.5. It's just not the best estimate I could get. And they're going to want the best estimate we can get. Well, that is the slope between 2 points, but I haven't moved them as close to 2.5 as I can. So instead of 0 and 5, I could say, well, let's use 1 and 4. I'm now moved closer, so my estimate is going to be better, but is that as close to 2.5 as I can get? And no, it's not. The closest I can get is if I find the slope using an x of 2 and an x of 3. So if I find k of 3 minus k of 2 over 3 minus 2, well, that's 10 minus 8 over 3 minus 2, which is 2. This is an estimate for k prime of 2.5, because I found the slope between 2 points, and move them as close to the 2.5 as I could.